Hello, today we gonna see the lead goal daily problem, that is to create a binary tree from pre-order and post-order traversal. So we are given a traversal, we need to create the binary tree from it. So there are multiple ways to create because there is uh, no fixed solution for the given pre-order and post-order traversal. So for this binary tree, we are going to find the solution. So now I can one of the scenario I can show you that for this pre-order and post-order traversal, we can have multiple solution. One can be this one, and another can be this one. You can think of any other scenario, but we are going to choose one method to proceed with our solution. So, with while creating a tree, we will going to traverse through the pre-order traversal and creating a node, and so on. So, for this, first we create the root node, that is one. Again, going to two. Again, we will create left child, right left child. If we are given only a pre-order, then we can create this by creating a left child. But there is a constraint of post-order. So what is the definition of post-order? It is that first we visit left node, right node, and then the original node. So here we will get to know from the first element that here we want to stop, where we want to stop. So 4 is the first node where we will be stopping our uh, iteration in the pre-order and move backwards. Okay, so my idea is, okay, let's I will create the node until I will see that the current index of the post or traversal matches with the uh, whatever node I created now. So here I see like 4 is matching with the 4. So I will be iterating backwards. I will be iterating backward. Now I will move forward the pointer, push order pointer. Here we will see like there is a 5 and there is a 5. So now here is a two possibility. One is that I should move backward to 1 or I should create a. So either you can pick the idea, but here I am choosing that if the two right child is not created, then I will create the right child. So here I will check, okay, two right child is not created, so I am creating the right child of 2 and keep, but the current pointer is again at 5. Now 5 is created, 5 is my current element. Now I will create a 3. Okay, so while creating I see like 5 matches with the current order, so I will have to return. So what will be, I will be moving again back to 2. Now there is a 3 in the pre-order, but we can't get 3 because 4 and 5 is already the left and right now. So we need to check first. We will try to create a left child, then try to create a right child. Now If both are present, we will do nothing. We will move back. So again, 2 has both child. Again, we will move back to 1. Now, what we will see? Okay, now my current node is 1. Current node in pre-order traversal 3. Now I will see, okay, 3 right, 1 right child is not present, not yet created. So I will create a 3. I will create a 3 and check. Okay, 2 is there in the post-order traversal, but here is 3. So while returning back, we also need to move forward in the index because 2 is 2 two subtrees is already created, so we don't need to check the constraint in the post first. So we need to move forward. Now again there is 6 which is not yet visited or popped up from the stack. So okay, now we have recently created node 3, but here in the post set it is 6. We will check. Okay, this is also not matching. Now we're gonna move forward. Again, check for 6. We will try to create a left node. Okay, here we created a left node. Okay, now we will check. Okay, 6. It is matching with the 6, so we don't need to move forward. We don't need to forward. So we have to return. Okay, I have returned. Again, while creating a 7. Okay, we will check. Okay, I have returned. So here is a last node. Parent node is 3. So for 3 I have already checked. Okay, left node is already exist. I will not create left node. Right node is not exist. I will create a right. Here we are our pure traversal right. So what will be the stack looking like? So I gonna dry run the whole scenario. Okay, so no, for there is a 4, 5, 3, 6 and 7. And for the post order we see 4, 5, 2, 6, 7, 3, 4, 5, 2, 6, 7, 3, 1, 2, 6, 7, 3, 1. So now we will try to create the node. So first it is for sure the root node. I will push into the it is the one first parent. Now for 2 again I will check. Okay, 4 it is not matching. Now again we have 2. 2 is not matching with 4. We create the left node. Okay, we will check. Okay, parents left node which does not exist. So we will create a node 2 and push it into the stack. Now again we have 4 node. We will check. Okay, parents 2's left node does not exist. We will create a 4 and push into the key stack. Now we have node 5. Before creating a node we will check. Okay, this is the return, so I cannot create the child of this parent because the portion will traverse. I am iterating back, so I will pop off from the 4. Again for 2 we will check. Okay, left node to exist, yes it is existing. Right node exists, no it is not existing, so we will create a row at 5. Now we need to proceed in the post order because we have already eliminated the 4. So 5 we will push into the now there is 3. Now I will check. Okay, first parent element is matching with the post current post element. Okay, so we can't create the child of 5. I will eliminate the 5 and move to the 2. Now here again 2 is matching, so I cannot create the 2 child. So I will move forward. Now okay, so for 1 I see like okay 2 is the left child, so we can't create the left child, but we can create the right child. 3. So we will creating right child and push it into the stack. Again we have next element is 6. We will check. Okay, 3 is matching with 6. No. Is 3 left child is present? No. So we will create the left child, that is 6. I can push it to the stack. Now comes the 7. Before creating element, we will check again. Okay, 6 is the parent element, but it is we can't create the child of 6. So okay, we'll pop this and move forward. Okay, now again we will check. Okay, 3 is there, but 3 is not matching with 7, so we can create a 3 child of 3, but left child is already created, so we will creating the right child. In this way our pre-order array is over and my traversal will root tree is already created. So what are the elements that we are left over? We are left over with okay. We will create we will get into this step. This 1, 3, and 7. So at the end, my traversal will contain the only the rightmost right view of this, because we are not. So if there is a next element possible, if there is a possibility of let's say 8 element, so what will be the current parent is 7, current parent is 7, so 7, but okay, so 7 is already there, we can't create, we will be popping back. Now move to 3. Okay, 3 is popping back. Now move to 1. 1 is popping back. Now a stack is empty, so 8 can't be the element of pivot. So you understood that this is one of the overall time complexity you can think of is linear time complexity, or O of n to traverse a pre-order traversal plus O of n to push element to the stack, push and pop, push and pop. Space complexity is again O of n into 2. So overall time complexity is linear. So now we will going to see the C++ code. So first first okay, so first we will creating the root node, which is obvious the first element of the pre-order. We here n is the number of node, and we will maintaining a index pointer for the post stack. Again we will creating a stack to access the last parent node. That is, after creating 4, we need to iterate back to the 2. Now, after creating a node file, we will need to iterate back to 2, but 2's child is already created, so we can't create. So we again move back to 2. So that's why we need stack. We will be pushing the into the stack and iterating from the first because we have already created the root node, that is 2 1 here. So before creating a node, we will be eliminating those parent which child already uh, what we call post or in the post or traversal does not allow the node to create the child. That's why we will eliminate it until like I exceed the array length and the post element is matching with the top element and incrementing the post pointer. Now we will try to create the first node, that is left child. Okay, so we will check, okay, if left child is not existing, we will create the left child and push into the stack. If it, again we will check, okay, if left node is already there, so we will check, okay, left node can be created or not. Again, doing the same operation and finally returning the root. So you can see. So this is the solution that I have already submitted. So I will be showing you that it is accepted. So thank you.